Law of cosines. When you're given side angle side, 10, 14, and 97.1, okay? Life's easy. Because you know already from the first assignment, b squared equals a squared plus c squared minus 2ac cosine of gamma, or beta in this case. So 10 squared plus 14 squared minus 2 times 10 times 14 cosine of 97.1 equals a big number. Second square root of the answer equals the answer we need, 18.1826. And then we just use law of sines after that. The sine of 97.1 over 18.1826 equals the sine of gamma over 14. Cross multiply, solve, we get the answers. We've done that, all right? We did 2 problems like that. But then, when we get to side, dun, 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 you have to do algebra to figure it out. Why do we have to do algebra? Well, they're looking for alpha first. Really, you can find any angle first, but let's find alpha first. Either want to find the biggest. I generally like to find the biggest angle first, opposite the longest side. Because if it's obtuse, it's obtuse. If it's acute, it's acute. But you know that if this is the biggest, the other two have to be acute. Why? Why do the other two have to be acute if you found the biggest angle is either obtuse or acute? Biggest side goes with the biggest angle, and you can only have one obtuse angle in a triangle. So the law of sines, the reason why we have the ambiguous case is you don't know whether that other angle is acute or obtuse, so then we end up with 2 triangles. Well, if you find the angle opposite the biggest one, then the smaller two have to be acute. They can't be obtuse because this is the biggest one, okay? And the other angle can't be bigger than the biggest. Okay, so we're finding A first. Finding A first, alpha. So we write down, well, it's A squared equals B squared plus C squared minus 2B C cosine of alpha. And you're going, well, why did he pick out that formula? Well, if I want to find alpha, there's only one law of cosine formula that has an alpha in it. And that's the one with A squared. There's only one with beta in it. That's the one with B squared by itself. And the only one with C or gamma in it is the one with C squared by itself. So I have to use this one. Now you know why I have to do algebra. I got to get the cosine of alpha alone on one side of the equation. So if I have to get it alone on one side of the equation, I got to get everything else over there. So my first step is to square everything out. So 420.25 equals 182.25 plus 201.64 minus 383.4 cosine of alpha. All right. Now what? Well, let's just add these two together. Okay. Now, can I take 383.89 minus 383.4 is like 0.59, right? No, you can't do that. And you go, well, why, Mr. Bierschbach? Well, let's look at this. When you're solving this equation here, do you add the 4 plus 2 to make 6x? No. What do? Well, you subtract 4 from each side to get 2 equals 2x. So x equals 1. Okay. So on this one, we cannot subtract these two because there's multiplication here. So you have to move this to the other side first. So you take 420.25 minus 383.89. 36.36 equals negative 383.4 cosine of alpha. Divide by negative 383.4. So the cosine of alpha equals it's a crazy decimal. Negative 0.09484. But to get the cosine alone, I move the cosine to the other side. So you leave what answers in your calculator and go second cosine, second answer equals. So that's a 95.4 degree angle. $95.4 degrees. And now, look at what we have. We have opposites here. And if we have opposites, then we can use law of sines. The sine of 95.4 over its opposite side, 20.5, equals, if I want to find beta next, it's the sine of beta over 13.5. So you take 13.5 times the sine of 95.4 equals divided by 20.5 equals second sine, second answer. Because if we're looking for the angle, we go second sine, second answer. And it's 40 point, well, it's actually 41.0. And these two add up to 136.4, and 180 minus that is 6. 343.6. There we are. Law of cosines. Okay. This is side angle side. I think we're good with that. Let's do another side one. All right. So A is 24.9. B is 15.9. C is 20.4. A is the biggest, so I want to find angle alpha first. So 24.9 squared, A squared equals B squared, 15.9 squared, plus C squared, 20.4 squared, minus 2 A or 2B C cosine of alpha. Okay. Now that I understand algebra, this is my little cheat that I do. I do it mostly all in the calculator. So I'm going to take this minus this divided by this whole quantity here on the calculator all in one step. But to do that, we got to put parentheses around this. And you go, whoa, Mr. Bierschbach. Well, I'll show you on the calculator how it works. So I'm going to go parentheses. Whatever's on this side, 24.9 squared, minus this and this, but I'm going to subtract them each because if they're on this side, to move them to this side, I have to subtract them both. So I'm going to subtract them both. So minus 15.9 squared minus 20.4 squared. And then close my parentheses around that. So these are all in parentheses. And then I'm going to divide by and then start another parentheses. Divided by and start another parentheses of this stuff right here. 2 times 15.9 times 20.4. Okay? That's all in one line. So you know how up here I took all this stuff and was working it out and did so many steps. Well, if you write it out, and do this minus this divided by this whole quantity, you get a decimal. And that's what the cosine will equal. So if you do second cosine of the answer, you get my angle a lot quicker than the last time I did the problem. Okay? Just understand the algebra, understand how to write out the problem. Okay? This squared minus this squared minus this squared. All in a bracket, all in parentheses, divided by this whole group squared. And then inverse cosine of the answer. Then, once you get this far, it's just law of sines. The sine of 94.3 over 24.9 equals the sine of 15.9 over beta. Cross multiply, solve, you can do law of sines. Okay? You can do law of sines. Now, it says determine the number of triangles with the given parts. So we draw a triangle. So I'm going to go alpha, beta, gamma here. Alpha, I don't know. A is 7. Beta is 80. B is 4. Okay. This is a side-side angle, isn't it? Two sides and an angle not in between. Side-side angle. So this could be 0, 1, or 2 different triangles that look like this. Okay? So what do you have to do? Well, you have to do what we did before with the law of sines. And what I should do is really move these around so they're in the appropriate spots. 80 here, 4 here, 7 here. Yep. And so then if we have an obtuse triangle, so obtuse triangle, Mr. Bierschbach, 80, 7, and 4. And let's see if this works. So if we cross multiply, sine of 80 over 4 equals the sine of, so if this is beta, I think they gave us, right? Beta and alpha and gamma. Sine of alpha over 7. If we cross multiply, what's 7 times the sine of 80? That's 6 point whatever divided by 4 is 1.72. Second sine, second answer. What do we have? Domain error. What we got here is a dangle problem. It's just a dangle. It's not a triangle because it's a dangle, because it's got an end that's dangling out there that'll never hit the other side. Okay? So if you got a dangle, there's 0 that work like that. Okay? Let's look at this one. Alpha, beta, gamma. Actually, it's a obtuse triangle. So this is 100, this is 40, this is 30, and this is 13. Okay, you got to figure out the other two sides, right? What do we got going on here? We got angle, side, angle, yeah. How many triangles can there be like this? I'm a failure. I am just such a failure. There are 0. Because you only have 170 degrees, so this doesn't even make a triangle. All right. Woo. All right. For this one, you'll have to use the law of cosines to see if you get another side. Okay. Could there be 2 different triangles with 179 in each of them? No. So the only possibility is 1, or if law of cosines doesn't work for this, then what do we have? 0. Okay. And the same with this one. This one is BCY. So 45 here, 2 here, 7 here. You got to see if it's a dangle or if it's triangle. If it's a dangle, you got 0. If it's triangle, you might have 1 or 2. Okay? So it's the side-side angle problem. Okay? So you check side-side angle. Okay, so those are the 8 problems for you to do in your second assignment. On Thursday, we'll look at areas of triangles formulas. Areas of triangles. And we might start with vectors. We'll see how things go. I think we'll do vectors as well.